My name is Vivian. Welcome to our event. And tonight we have two students going to present their second project when they're doing the bootcamp. So we are a data science school. We're mainly doing corporate training and individual training, either on full-time base or part-time base. So if you're looking forward for a transition to become a data scientist, you can consider either our full-time program called bootcamp or our part-time class. Next round starts on September 20th and the 21st. So we train people in R, Python, and Hadoop. You can go to our website, check out the bootcamp, and check out the course. Little bit background about who we are. I started the meetup in May 2013, and at that time I was doing a lot of volunteer. I was cook food for homeless, and all of a sudden I decided to teach people. So I started to teach R for free in my meetup. And about November, I started to get encouraged about training people professionally. That's how the school starts. And right now we grad 2 bachelor bootcamp, and we're doing a lot of corporate training. And this is the time they can teach more people to share the skill set. So our meetup mainly set up like a workshop. We expect you to learn, be able to download the code, be able to follow along. So it's not just about how awesome they are, and you can become the same level of skill if you really latch on what they taught here. So I hope you can pay attention, ask questions, and get yourself familiar with this shiny technique. It's super useful. We saw a lot of corporate and the government are doing shiny apps in replace of traditional dashboard like QuickView and Tableau. And R is super flexible. You can build in machine learning, you can build in visualization, you can connect R with D3.js. So there are a lot of cool stuff about the Shiny. And there are just 2 apps here now, and every bootcamp student made their own Shiny apps. But those 2 are willing to share tonight. So, and next week we will have machine learning project, and next week we'll have the capstone project demonstration. And this time they did a project for Fusion Media, which invested by ABC and Disney, and they were looking to find what is the social media super fan, who is impacting and help you to pass the message along. So it's going to be really useful if your company is doing social media campaign or marketing. Okay, so let's get started. I want to do a quick survey first. Who have learned R before? Really good at R. You guys are so humble. So how many of you know Shiny? Use the Shiny or have seen Shiny? Seen it, okay. Do you like Shiny?
Yes.
Do you know any problem with Shiny? Do you know any problem with Shiny? Or people really do Shiny? Like bandwidth, if some of the people using the same Shiny, it's gonna cause problems.
We haven't tried many at the same time, but so far it works.
It works very well.
Access problems sometimes. Different people to data, it's going to access the data, but that's a different access problem.
So if you use Shiny in production environment, you need professional Shiny license. You also need to host with like AWS, so you can boost up the capacity. But it's not a problem. Okay, so the first presenter is Luke Lane. He's going to get his Ph.D. in December, and he's looking for a data science job. If anyone of you hiring or know someone's hiring, feel free to talk to him. Okay, please.
Okay, so what's wrong with this? Okay. So, hi guys, I'm so glad that you guys are here. And my name is Luke Ling. My official name is Stony Brook. And I'm gonna present you a little toy built in my bootcamp, which is called a visualization strategy backtest. And the strategy I'm talking about here is a trading strategy. Of course, as you can see, I have a curve of the price here, and you know, buying and selling signal, and it tells you the return here. This is the user interface that we're gonna see in the next half an hour or so. And okay, so basically, I'm gonna present you two parts. One is what I use, the tools I use to construct my app, a Shiny app, and the other is how I use how we can play with it. Okay, so basically, what I use is R and RStudio. So RStudio is just the integrated developer environment for R, and I also use Shiny app package. Shiny is basically help us to build up an app. And also because I'm dealing with financial data, so I use this package called Pump Mode. Basically, you can use it for a lot of different financial work. Like you can download the data from they build an API for you. So what I use here is actually from Yahoo Finance, and it's very easy if you use a Pump Mode. Very easy to get the data. And then you have to do some computation on the data. And basically, data is in the form of so-called XTS, which is time series object. Okay, XTS is a time series object. And basically, I built this app for to build a trading strategy from technical indicators. I use a very easy ones to show how this can be done. And then I can visualize the result of each strategy. And then because we can see the return, and it should be very straightforward to see what went wrong in a particular period. Then we can modify it with some other indicators. Okay. So first thing I will do is to demonstrate my app. Okay, where you can. This is the link to my GitHub. Okay, you can simply click on it, and all the files are in the directory Shiny backtest. Basically, the important ones for all the Shiny app, if you want to build out the Shiny app, you have to construct a user interface, which is the file that has VUI.R, and then you have a you have a platform to do the backend computation, which is server.R. And I also construct the helpers file that I collect all the functions that's using server there. So if you want to run the app, you have to download these three files. And when you don't have internet, you can use if you don't have internet, you probably have problem to download them. But anyway, you can use these data to play with. You don't really need to connect to Yahoo to play with my app. So after you download it, you could run it in RStudio. So basically, this is standard. What the RStudio looks like. Here you see the script. This is the editor, and this is the console. You can do the computation here. And this part tells you in your environment what kind of function variable you have. And here you can, if you ask for some help, it's going to show here. If you plot some graph, it's going to show here. Okay, so this is what it likes. And for all the Shiny app, you actually have a little round at bottom here. If you click on it, you will see your app. So okay, this is my Shiny app. Can people see the green line? Yeah, so this is the daily close price of S&P, actually SPY, which is an ETF that tracks S&P 500 indices. Which basically means if S&P 500 raised 10% today, the price of SPY should raise 10% also. Okay, and this one is easy for you to buy and sell. You don't have to buy 500 stocks and wait it, allocate it to track S&P 500. Okay, and the green line you see is actually the adjusted close price. Okay, when you download the financial data from Yahoo Finance, it gives you the usual high-low, open-close data, and also the adjusted one. What it means is if you have a split in that day, it's gonna change all the data before for you, so that you don't see your price become half or even lower suddenly. Okay, so so that is where the visualization happens. And you can see from below it, we have 3 columns. The first one allows you to select the data you want to look at. So SPY, as I said, is EDF, and also the date range. So you can change them. If you click on it, you see the calendar here, and you can simply click on the date you want to start. I'll show you how to make this later. Okay, and also the end date. And also you can click here to select the style you want, either the linear ones or the candlestick. So if you're familiar with financial data, you see people often visualize as a candlestick. You can see a little bar, either green one or red one every day, that tells you the open, high, low, and the close price. And if you click, in this particular app, if you pick the candlestick, the price is not just adjusted. Okay, it's just whatever price it is at the day. If you choose a linear one, it's gonna feed back the adjusted close price. Okay. As I said, this gives you the data, and I would like to build some strategy. As I said, I'm gonna build a strategy from the technical indicators. I picked 2 of the most, the easiest one and very popular ones. They are the Bollinger Bands and NYC. Okay, let me first show you what the Bollinger Band is. So what you can do is simply click on Add Bollinger Band and submit it. Okay. So now we see a band around the price. The green curve is the close price. And the way we construct the Bollinger Band is at each day, you will use the price of the past 20 days to compute the mean and the standard deviation. You use 20 because you can select a window to be 20 here. You can change it if you want. And then we simply use the mean of the price as a center and construct a band by 2 sigma, because I choose the multiple of the standard deviation to be 2. So you just use the center and 2 sigma. So you will see that for different day you will have different bars around it. Okay, and just connect all the bars. You see the band. That's how we construct the band. Okay, so you can change it if you want. So you can, if you want, you can change it into 40-day windows. Okay, as you can see that the shape of the band change, which looks better. It doesn't vibrate too fast because of
This is a browser page you're looking at right now, right?
it's a local. Yeah, it's a browser page, but it's hosted locally. Yeah. And you can change the width of the band. If you want to be more aggressive in trading, for example, you can change, instead of 2 sigma, you can change it into 1.6. So you see it become narrow. Okay. Now, basically, Bollinger Band tells you how much the price has to go in a certain period. So, and very easy, very naive trading strategy is whenever the actual price hit the bottom, you buy. Okay, whenever the price hit the bottom, you can buy, right? Because that's relatively cheap. And when you hit the top, you will sell. You will sell your stocks. So we can generate an order. We can generate an order. So generate an order, and let's neglect this part first. Okay. I only show you one order. So you see, when the price hit the bottom, I generate a buying signal. And after I buy, this is a simple holding strategy. Okay. So after maybe 2.5 years, your return is around 30%, which is okay for amateur, investor. And what about if we actually? So you can see there is oscillation. Okay. If you simply hold it for all the time, you miss the price difference here and here, right? You can make a little bit. If you follow the instruction of a Bollinger Band, okay? So we could click here, stop profit, means you're gonna sell it when it reaches the top. Okay? Now you make 41%, which is probably not that epic because S&P 500 performed very well in the past 2 years. So in this example, it's just 11% difference in the past 2 years. So let's see another example. If you look at McDonald's in the past 2 years, okay, and if you simply use a holding strategy. Okay, you buy here and just wait. Okay, you see, you only make 5% return. And of course, you can use Bollinger Band strategy. So this one makes a lot of difference because S&P 500 actually grows in the past 2 years, but McDonald's did not. And the price is never stable. If it's not going up or down, it's possible. And you will likely use it to make profit. Okay? And we can see another example, the Procter. Let's first take a look at the Citigroup, okay, which is just C. And if we look at a simple holding strategy, 14%, okay? And what about Bollinger Band? That gives you a 34. Again, Citigroup didn't really grow very fast in the last 2 years, so you likely use the oscillation to make a profit. However, if you look at a graph, as I said, because we have the visualization, it should be straightforward to see which part went wrong and to modify it. In this kind of, in this particular case, you see that it's very close to the ceiling of the band, but it didn't really reach it. Okay, and it goes back, and then go up. Still, it didn't really reach the top. So, if you want to modify the strategy here, what you can do is, instead of wait the price reach the ceiling, you can stop loss whenever the price goes down like 2%. You can keep updating your price, and here when the price starts to return 2%, you sell it. Okay. So what we can do is, yes, sure. Oh, sure.
There's a couple of places where you have selling, but use to ramp up a little bit.
Yes.
Over there and over there.
Yes.
Would it make sense to have two moving averages, one that's at 20 at days and one that's very short term,
Yeah.
and look at the acceleration so that you can detect those cases and conclude that maybe you should hold it a little bit longer
Yeah.
than.
You could do that. You could do that. I didn't implement that part here, but I did something very similar. When the price is strongly going down, and I want to suspend the buying signal, I'm going to show you with MACD, which is a difference of a 2-second fast and slow signal. You can, slow down your transaction so that you don't lose that much. But this part I'm doing, that is 100% right. There's you could do that. But for simplicity, we can, because it's visualization, you don't want too much information here. Yeah. What I tried to say was you could use stop loss. Okay. There. So I don't stop profit. Instead, I stop loss with say 2%. Okay, for example, to see what will happen. This time it gives you 48%, which is a bit better because you have used these, oscillating instead just wait for too long. Okay. Actually, an interesting observation is if you compare this one with McDonald's we did before, they both oscillate. Okay, but this one the amplitude contract. Okay, that's why you have to change the strategy. If you think about it all the way around, the return corresponds to different strategy actually characterize the stock price in certain period. Okay, that is another interesting thing. Okay, yes.
I've got two questions. So first is related to this now. So I can see the sell is lower to the buy at many places.
Yes.
And the second is, this is historical prices. So can we use this to our advantage to predict the future price?
That's what I was thinking. Because as I said, the return corresponds to different strategy. Actually characterize the price, right? So you can feed those returns in if you have a machine learning model, you could try to feed it there. And then use them to predict what's going to happen in the next second month or so. And as you point out, here we have some, selling that is lower than buying. That's a stop sell.
So my general impression of what you're doing there is it seems to say that short-term volatility is high, but long-term volatility is not, and you're going to doubt this.
You see that?
the short-term volatility is high in
Uh-huh.
a short time window, but in
Yeah.
the long term it's not, you'll make out for this.
Yeah. Yes, that's true. But basically, Bollinger Band tells you whenever the price goes down, you buy.
Yeah.
But that could be wrong because it might keep going.
You're counting on a long-term trend.
Yeah. All strategy has its philosophy. This one believes it's bounced back when it reached the extreme. When it's not true, you have to use another indicator to fix it.
To bail out
Hmm?
and cut your losses.
Yeah. Okay, I'm going to show you that later. Where will I? Okay. Also, so what I try to say is the return corresponds to different strategy also characterize the price. We're going to see that a little more later. Okay. And then let's take a look at another example. This is Procter & Gamble, which, again, it didn't grow in the long term. So we still try to use Bollinger Band to profit from the oscillating. Okay. As you see, we still have I didn't compare to the simple holding strategy. This one still is going to beat the simple holding strategy because it's not going up in the long term. It's oscillating. You have to use oscillating. And the interesting thing here is, in my strategy, I only allowed a long position. I didn't use any short position, basically because, again, for simplicity. Okay? So this part, when the prices keep going down in a relatively long term, it probably doesn't really make sense to keep buying and selling in this region. You buy here because you think it's in the bottom, so it's cheap. But not very long later, you sell it to stop the loss. Okay? But you buy it back right away because the algorithm is stupid at this point. They still believe that price is very low. However, it's not true. So what can we do? Here's where we can implement another indicator called MACD. The philosophy behind MACD is basically what this gentleman mentioned before, that you can use a fast indicator and a slow indicator. When a fast indicator go above the slow indicator, that means the trend is going up. And vice versa, when it's below the slow indicator, that means the trend of the price is going down. This is a momentum indicator. But I can show you the graph of it to illustrate what it is doing.
Sorry, what's a fast indicator?
Fast indicator is just the moving average in a shorter period. So it's probably the moving average in the past 10 days, the fast indicator, and the slower ones in the past, say, 30 days. Okay, so if the average in the past 30 days is lower than the average in 10 days, that tells you the price is actually going up. Okay, so this is the graph of MACD. What I actually use in this app is the shadow part. You can see here. They're actually histogram. Okay, when the shadow is negative, that makes it indicate the price is going down. When the shadow is positive, that tells you it's going up, even in a relatively small region. Okay, so what you can do is when you see the trend that is going down strongly, you should suspend your buying signal from Bollinger Band, and you should encourage to sell to stop the loss. So we can modify the strategy by considering MACD and to see what's going to happen. So let's see. Currently, it's 18% return. If you consider MACD, it becomes 26. Okay. Basically, that's happening because a lot of signal here is suspended. Okay, no longer there. They're no longer there. And we can see an even more clear example. If you consider USO, which is an ETF that tracks the crude oil, WTI crude oil indices. Okay, so we just consider a simple holding strategy here. Okay, so that's the oil price. We know that price is going down very fast last week. So if you simply buy a few years ago and hold it for such a long time, you're gonna lose 54%. That's a lot, okay? And we can consider to use Bollinger Band or use a stopping rule, okay? Again, 2% stopping rule. Okay, it's not gonna help very much because still we didn't avoid this part. So if you want to avoid losing in a strong price trend, you have to use MACD. Okay. So let's try MACD here. It is a bit better, become negative 23%. Still, you lose a lot, but that's mainly because you are using long strategy in the past couple years, which is very bad time for oil. However, if you somehow you have a domain expert tells you the trend is gonna be long time, okay, it's not gonna be short. You could somehow change your strategy. Don't use short-term MACD. Try to use a longer one. Okay. Try to catch a longer trend of the price to see what's going to happen. Now you make 4%. Okay. Basically, you avoid this very bad time, and the price getting stable. You know, when the MACD gets stable here, you notice it very fast, and you start getting involved to trade again. That's why you can make a little more profit here. Okay. So while you might want to say just quit oil. Okay, that's probably true, but for some reason, people want to get involved and people want to hold only long position, so they can use this kind of reference. Okay, so again, as I said, I want to put some emphasis on the fact that the return corresponds to different strategy that actually tells you something about the price. Okay, so if your optimizing strategy have MACD involved, okay, that probably suggests in the period you have a very big, downside in your price. Okay, and these are interesting because these features are purely quantitative, something you can feed into your machine learning model easily. Okay, so that's mainly the Also, you can beat some very good asset too. Like if you consider Apple in the past 2 years, okay. A simply holding strategy will give you 94% return. You just buy it 2 years ago and wait, okay, which is pretty good. But if you stop the loss at a 3%, okay, I know this because I tried that before. I optimize it manually, basically. Okay, you can get a little better than what you can. Okay, and if you want to be even better asset like S&P 500 from 2009 to 2013, or you want to beat the Apple from 2009 to 2013, these strategy doesn't work anymore because they're super. Like Apple, like 500% in that period. And it's mainly just going up. Just keep going up. So you won't make any profit by bet on that story. Okay. So that's a demonstration on the app. Is there any questions so far? Yeah? So all the signals are computed by the data before it. I don't use anything. Okay. So because the MACD is from the past, depends on the signal on past 10 days, past 30 days, and Bollinger Band is from past whatever windows you specify. They're already based on the past. Okay. So let's go back to my slides. Oh. Okay, so basically, I kept talk about the return actually characterized the price. Again, because they're purely quantitative features, you can feed into your model. That could be interesting. So that could, I believe that would be the next interesting thing to do. If you think about it, the strategy I implemented are relatively easy. They're just so if you think about how trader or how you would trade, everybody has a reasonable price in their mind. What would that be? They usually anchor to the reasonable price. Okay, so volume can actually catch that and catch how much that people would tolerate the volatility. Okay, so these kind of simple strategies actually catch the behavior of the market to some extent. I would be very interested, what it would result in if you feed it into a machine learning model. Okay, and then I'll show you how to construct this kind of app. So this is what we saw in my app. You have different columns, okay, and you have every different elements. You have the type and the slide kind of input. How do we construct those? It's actually very simple. So this is a shiny. This is our studio we saw before. What you need to do is to source the shiny package first of all, and then it's very simple here. That this plot output function will fetch the output from your server. Okay, this is a user interface. This is UI, and this function in the user interface is gonna fetch the output from the server. And you don't want other part. You only want the plot. So this function shows you the graph, the price and volume of and return everything there, simply by this function. Okay, and below the graph we have different columns. Okay, and you line up all the elements in your column here. Okay, to construct those columns. So for the simple part, you have a text input which allows the user to type whatever they want into the server. So the first one, sim, is an input ID. I'm going to show you how to use input ID later. And the second argument is just the text shows here. Okay, SPY is a default input. Before I actually type anything, it has a SPY here. Okay, and the date range, which you can drag the calendar here, each part, you usually use a date range input. Okay, and again, the first argument is input ID. This one shows the title and the default value of the input. And for the slide one, just slider input, you can specify the min, 14 days, and 6 days maximum. Okay, and 20 is the value, the default value. Step tells you how much you can move each time you move 1 day. Is there any question? Okay, and there are some other elements here. I'll let you. Vivian's gonna send you the slide later. Okay.
Yeah, if you sign up, I have your email address. Please send me the slide.
Those are very simple functions to use to construct your app. And then quant mode. That is the main package I use to deal with the time series. Okay. So this one, the get symbols, is a function from the quant mode, where you can specify the source from Yahoo Finance, and the first argument is the symbol that you want to look at. So basically, if you remember, we have an input ID in the user interface. So if you type the symbol you want in the user interface, this input $$ will fetch it. And if you put it here in a get symbol function, it's gonna download the data of that particular symbol. Okay, and again, input dates, the starting date and the end dates. Okay, and then you return the result to the server. Okay, and chart series function is again a function from quant mode, which allow you to sketch the price in your graph. And except the close, beside the curve of the price, anything else you saw in the visualization was treated as a technical indicator. Okay, so so you saw the Bollinger Band there. That is constructed by the add B bands function from quant mode again, and this function will construct an object as a technical indicator. And if you want to show it in your graph, you have to put them into the show function. Okay, so still it's very easy, and you can customize your indicators. Yeah?
Did you make the add B bands or the alpha make that?
The quant mode made that. Okay, all you have to do is to specify the windows and the marginal of standard deviation. Okay? And you can easily construct your own indicators, like all the buying signal and selling signal. Those are point-wise indicator. You have to put the information into your add points function. Okay, so though they are time series, they are treated as a sequence. So you have to specify the indices where you want the point to show up. Okay, so basically, I construct a strategy. Okay, when the buying signal is not empty, I want it to show up there. Okay, and these again, the indices are where the buying signal is not empty, and the height, the y means the height as usual. It's just the price of that. Okay. So this is the typical time series I use to sketch the graph. Basically, adjusted price is just a price I download from Yahoo Finance, and I use the quant mode, the Bollinger Band function, to construct this. Basically, when the percentage of Bollinger Band equals to 1, that means it's in the top. And when it is 0, that means in the bottom. Now if you have negative 21%, that means it's below the bottom. That's why we have a buying signal. Okay? And if you want to sketch a graph, you want to buy is exactly where the close price is. You have to put the price, the close price, in that column. Okay. Okay. So these are the functions I use to decide the trading signal. Basically, I put the percentage and MACD into it. If I don't have any MACD, I just use. If I didn't modify the strategy by MACD, basically I will have empty for all the MACD column. In that case, whenever the price is below 0, I will trigger a buying signal. Otherwise, I will use this one. When MACD is very negative, then the percentage has to be very much below 0. Then the buying will be triggered. That's how I suspend all those buying signal when MACD is very negative. If you imagine that MACD is negative 1, then percentage has to be negative 0.3, so that the buying signal will be triggered. That is actually very hard. Okay. And also I have a function for triggering selling signal and also the stop selling signal. And these functions can be collected in the helper function, so that you don't see all of them in your server. Okay? All you have to do is just source them in your server. Okay, and that's it for my presentation. And this is about myself. I'm Luke Ling, and I'm Ph.D. in mathematics. This is my email. And if you're interested in the app I constructed, you can download it here, and this is my LinkedIn. Any questions?
Just kind of a very generic question. Out of curiosity, this inventory trading strategy ended up making some money for you?
Oh, not yet.
Not yet.
Not yet. Okay. If you probably already noticed that I don't have any prediction in the app. It is completely just backtesting of the strategy. And
But it can still be used to make a future trading strategy based on the way you have designed it.
you can, yes. But the thing is, how do you decide a window? Is a 40-day window the best or 30-day window the best? I don't have any prediction in the app. But however, you can simply by back testing say 40 days window is the best for the past 3 years. So I'm going to use it in the future. You can try that, but I doubt this is the best way to do it.
Have you tried it? Like, on a real time data?
No. No.
What's the licensing on Shiny? I know ours are open source.
I think that's also open. Xavier mentioned that if you have to, you have problem with capacity or something like that. He's asking about the licensing.
What is the licensing on Shiny?
Licensing?
Yeah, software licensing.
It's ours to Shiny professional license.
Okay, and is it like that? MIT license, GPL?
I think it's commercial license.
Okay.
And,
Does this work on the last 10 days of the last 2 months? It's easy. It works on the last 10 days.
the last thing?
Yeah, last 10 days. Can you run it for last month or so?
Oh yeah. You can learn
Who wants to see it now?
the last slide.
Yeah.
Uh-huh.
On the chart, yeah. Can you go back to the chart?
Yeah, the original.
Oh, the app you
Yeah.
said. I'm sorry.
The 725 in that dating.
Daybreak.
Can you do it little bit recent month or so?
Month. Okay.
August, 2015.
So let's start from August. Is that?
608, yeah.
Oh, there's a little problem because I use 40 days window. So if you use only 30 days or so. there's-
June.
Yeah.
June.
Okay, you want to use June? Hmm? Good. So what's wrong with this?
It works from August to 1, maybe up to 15 August to 12. So 15 July it works. After July,
What's wrong with it? So let's forget about bond you can just see what happens. It's still invalid. So weird.
Do an ETF. Go back to this, the S&P.
Okay.
it works from 721.
You say 121?
721.
I don't see what's going on. Yeah. Okay. Refresh it.
Okay.
Okay, and then go back to 15. Okay, we have some.
What do you want me to do? This is, I just want to do that.
Any other-
Poses a question on Shiny, so there are pretty technical people. They kind of happy to accept all that and figure it out. We try to do that with those apps for people who have no technical background. Maybe science, statistical work. So spend a lot of time almost doing software development, patching those things, or just doing the wrong thing, something else. So yeah, I mean, I know this is the expression of this month, so they like to push on this the more public they get. So this is back to investing in software development, sometimes use user entry or funky things like this.
Can you try adding the bounded bills back into
To here? So you will see that for the first part, there's no bands. And
Okay, so that's a one.
Can you use multiple stop?
oh no, not in this. I didn't put that. Any other questions?
what you see does not show today's price. Does not show today's price.
Oh no, not yet. I'm not sure if Yahoo Finance already because I'm using Hotmail.
Yahoo should have it, but I'm not sure why. See, you are waiting for the post price, then you want to get.
Yeah, here's also after sure. I don't really know how they decide the post price.
If you cannot get the difference instead of depending on the post price, you might want to look at the post price.
So you can download
Post price is
data.
not available.
Here's the data.
Okay, guys. We will take 2 minutes break, and next gonna be MTA data. And Xavier was a quant on Wall Street and got a Master of Finance Maths and Urban Science, and he's using both Python and R Shiny to do this project. And it updates every 10 seconds automatically. So you can see where is the fastest subway. So 2 minutes break. If you need to grab water, grab more food. Okay?
Turns out MTA has a 1 minute cache. So when you read it every 10 seconds, you're getting cache data.
Oh, okay.
I'm a
Great.
developer for MTA.
Yeah.
Ah, I
Oh,
see.
it depends which feed you're getting, by the way.
The API all time, the one on the website.
Uh,
Yeah, I'm sure that there is a delay
It's
and
on- it's on our
everything
website.
is expected time.
The Siri one, the one. All right, the one. Here, hold on. I probably have it right here. Let's see.
Yeah, there's many problems. It's expected time, it's not real time.
Yeah, that's in GT. There's a GTFS feed.
Yes.
And then there's the
This
Siri
is one I
feed.
use.
Well, GTFS. It's they claim within a minute, but it's cached. So if you keep hitting it over and over again, you're just getting the same numbers back. Let's see.
First of all, these are very easy. Logging them very easy to visualize. And this app was supposed to be a visualization app. And another thing is, I tried to keep everything simple.
No, there's the GTFS feed.
Because my purpose was not to
Let's see. You can do better than that.
successful strategy at that point. I wanted, to catch the behavior of the market in some sense. I believe that. So first of all, they are very easy, and they kind of mimic how people trade. As I mentioned, they have an anchor of the price. They call it a certain kind of market. This kind of buying what is trading selling in the expensive price mimic how people. And I hope that this kind of the return will show catch some of what people are doing in the market and so maybe
Using those habitual actions, playing off that.
you mean the machine learning part?
Yeah, no, I usually like these tweets. Usually try marketing.
No, not at this point. Because I'm interested in machine learning. I'll make sure that these information actually tell me something.
Sorry, no,
I don't want to rely on
You're right on.
the backtesting is good, and then I usually train it for like a no region. I hope to figure out what these steps right here.
But
Okay,
that
let's
feed
get
is
started. Daddy, can you go this side? Guys, we're getting started. MT data. And Daddy has a little story why he did this project.
No. Hi. So I'm going to present a Shiny app where I use the MTA data feed. So first, let me tell you a little bit about me. So I would like to change career to be a data scientist. I have a master in urban engineering and I was specialized in hydraulic algorithms. I have a master of corporate finance. I worked several years on Wall Street. And last year I started to get the actuarial certification. I already passed 2 exams. And over the last 3 months, I spent my time downstairs at the New York Data Science Academy to get more knowledge in coding because I'm not a programmer. So we learned R, Python, data mining, machine learning, Spark, Hadoop, and I made 5 projects, and this is one of them. So you have my email and my LinkedIn, and obviously, like Luke, I'm looking for a job. And I'm not used to Mac, so I did everything with a PC because I'm a PC user. My next buy will be a Mac. So there are some slight differences, and you will see during the presentation. So just to give you the guideline of the project, we had 10 days to deliver something, and we had some advice from our teacher, was Jason. So this is not his exact words, but he told us you need to deliver something on a due date. You need to scale down your project if you want to deliver. You don't have to build the most efficient code, but you need to work. And you need to have a story for the visualization, because the visualization by itself has no meaning. So my story is the following. My sister-in-law, who lives in Yonkers, has been telling me several times that the 1 train, which is actually a local train, is actually much faster than the 4 train, which is actually express. And my first reaction was, I'm really surprised, I want to investigate. So this story, I used this story for my Shiny app. Sorry. And you have the link of the GitHub, the Shiny app, where there's a little issue because this is on the server of the school, and I think they forgot to upload one of the Python package, so one of the features is not working. And you have the blog. I made a blog. I wrote a blog for the app. So if you want to go back later, you can read the blog about it. So this is all the files that you will need to replicate the Shiny app, and I will go I will describe very quickly all the files in a minute. So my first challenge was to go through the MTA website. So we have a developer on MTA. So it was a real challenge. It took me a lot of time to understand and to actually go back to the pages where the files were. So you most likely know the first one, the mta.info. So you have a lot of information on it. I actually use that. I actually use the delays, and I'm going to talk about it later. And for the map, which is the first thing that you will see when you open my Shiny app. So actually, I can show it to you. So this is my Shiny app. So I generated this picture with R by downloading all the data from the mta.info. And this is the study of the travel time from the Yonkers to Lower Manhattan. So the analysis is the following. So this is how much time the 1 train is taking for every single depart time. And with the Shiny app, you have the possibility of changing to put another line. You can put both lines together to do some comparison. You can change the direction. And I add an option to show the delays, but this is not really helpful. So it tells you actually every single bit. It tells you that that at this particular time, this train was on the track, and a delay occurred at some point. So it's not really helpful. And you also can change the if you want to look in detail at the peak hour, for example. You will see that between 7 and 9 a.m. Apparently, the one train and the 4 train have approximately the same speed.
How frequently is this divided? Every minute?
No, our this is so yes. Every single point has an abscissa. So I will explain you my methodology to track the train, but given the amount of data that I had to download 2 months ago, given the fact that I'm a junior programmer, I'm going to explain you the methodology, and this is not every single minute. So that is the real time. That's I'm going to show you later, and this is pretty much my Shiny app. Sorry.
There are several ways of determining whether a train is late. Sometimes you can compute endpoint to endpoints and determine what the total run of the train is. Sometimes you look at the individual station and measure time between trains. Sometimes it's done by comparing a scheduled departure time with the scheduled arrival time with the actual arrival time. Which of these did you look at and what?
I'm going to talk about that a little bit later in the presentation. So just to give you an idea, I put all the links that I used because I had difficulties to go back to them. So the first one that I'm going to show you is the developer data term data. So you need to click on yes, and then you have a bunch of data that you can use if you are a data scientist. There's a lot of data about how much you use your card. I think there's some data about the bridge and tunnels. So there's a lot of good data for data scientists. So if I take the transit subway, and I lost my yes. So there is several files. I spent hours trying to find out what they were. The most interesting one are actually the shapes, because the shapes contains all the coordinates for every single train, and so every time that the train differs by a small direction, you have they provide a coordinate. This is how I'm able to actually draw the map. You have another file which contains all the stops. So this is the same thing, but you only contain the stops. And you can see that there is a code for every single station. The route is actually interesting because there is a color. So the color is the last information. It took me a while actually to find it. You are missing a dash to get the hexagonal, the color index for Python or for R. So the Shiny app, this is the structure for every single Shiny app. So Luke talked about it a little bit. Usually you put all your data files in the data folder. The table W contains all the pictures that you want to put in your Shiny app, and also contain all the CSS code. If you have any, in fact, if you are not happy with your Shiny app, or the Shiny app look like, you are able to change. You can change it. You need to know the code, which I don't, so I didn't use it. The global R is just a file that contains a global variable. The helper contains all the functions all the functions. The server is all the instructions, and the UI, which is the user, contains all the accounts and all the layouts. All the information regarding Shiny are actually in this website, which is extremely well written. There is a tutorial, there is information. If you need something, there is no other way to find it to build this website. So first, I'm going to show you how to draw the map, just to give you an idea of the code. And the inspiration for the map was taken from this map that was shown to us by Xavier during the bootcamp, and it presents the city bike journey in London. So for the busy axis, you have the yellow and the thick. For the lowest, for when you have a lower use of the bikes, this is in gray. And sorry. So this is the code. What I did is actually I used dplyr, which is a package in R, to actually aggregate all the information regarding all the files, all the shapes, which contain all the coordinates, and I put it in one single table. So this is why I froze most of the code. But if you want to reproduce everything, since the MTA is actually just extending one of the line, they actually updated most of these files. And then I built a function using ggplot, which is the best at this day is one of the best package to draw maps or to draw graphs. As you can see, I am only selecting these subways, and I'm going to filter the files using these lines. So the code is simple. This is just a filter, and then I plot the. I'm going to plot the files using the ggplot. So since I was using a PC and this is a Mac, I'm going to have some slight difference between what I showed you earlier and that. So I can actually change the size of my bus lines. And I put an alpha alpha being the transparency here. That will allow us to actually see to see the road where there are several buses. So you can see, for example, on this line, on this road, there's many buses. There is many buses on the Fifth Avenue, and on some other places, you have only one line. This is why this is a really light gray. As you can see also that this is updated. The 7 line is actually going to the 11th Avenue since beginning of this month. There are some slight issues. For example, here this is the S line, but the data from the MTA tells you that this is the orange line. The line in Staten Island, I had to remove it because it was messing up my graph. So I removed it. I didn't have time to actually check why there was a point there. And on top of that, you could add, for example, all the stations because they provide you all the coordinates. So, any question? Why is
Do
my
they publish crime stats too?
not as I
You
know?
didn't come across that?
Stats are available on the 311 database.
This gentleman here did census. Did you announce that yet? You did the census for the MTA, right?
Not the sense I did the train scope and station and make the
Look,
announcements.
I lost my
That's
PDF.
customer.
I lost my PDF.
I've also examined the feeds and the analysis on schedules versus
Okay. Yes.
You run similar factors to plan service outages?
Sorry?
Are you factoring it for planned service outages? Typically, you'll have express trains running local track, like the one train.
I'm not able to detect it.
But
I'm
they
not.
post it.
Sorry?
But they probably post it.
Actually, if you look at the detail of the data that they provide, everything is provided in a file which has been built by Google. So Google provides this standard file to every single city. The MTA feeds the data as they wish, and Google redistributes the data. But 90% of this file is empty. So you can only use the data that they gave you. I didn't find anything to see when a train was actually was going express when it was supposed to go.
No. When they do maintenance on the trains, they will frequently say for the next week, the 2 and 3 trains are running local the whole
Yes.
week. And you would expect to see longer times from the 2 and 3 trains. Just because they change the service.
Okay.
And if you track this over time, I'm sure you would see significant changes
Possibly,
in
yeah.
the new travel.
Yes. I did not check for that. So the second part here is the travel time study. So the goal is to actually calculate and visualize the travel time for the line 1 and 4. What you need to do is, if you do that, is actually use Python. You can't use R at this, currently because R does not support this package. So this is why I was using Python. I was using Python to download the file. And this is what it looked like. It looked like a JSON file. We had some properties, so it's extremely easy because there's some code online to actually to use it. So it's extremely easy to use. one of the mistakes I did is to actually download the data, historical data every 5 minutes, which was a mistake afterwards, but we had only 10 days to do it, so I had to deal with my mistake. If I had to redo it, I will decrease the frequency to less than 90 seconds. 90 seconds being what I understood, you will correct me if I'm wrong, 90 seconds for a subway is, on the sign in the subway, if you see that the time didn't change 90 seconds, for 90 seconds, that means that the train has been stalled somewhere. So if you manage to download the data for less than 90 seconds, you will get a huge amount of data, but it will be more practical than the 5 minutes that I use. So here's the methodology. One of the things that surprised me, and I was at the end of the time, of the limited time, is that the train IDs are actually fed in the on the terminal, 242nd Street, and you have 3 types of train. You have the one which actually leave on time, so they leave immediately. You have the one that leaves 25 to 35 minutes later, and you have some trains that never leave. So, in order to remove them, to remove these 2 cases, I actually track the train on that were passing the 238 station. One of the things that I need to mention is that the real-time data feed is actually always in expected time. This is not real time. So they give you the expected time of arrival to a station, and they give you the expected time of depart from this station. When you look at the data carefully, usually the depart time and the expected time of arrival is exactly the same, which is a little bit disturbing, because that means that everybody gets on the train immediately.
In that case, can you rely on the schedule, public schedule?
Public schedule is different words.
Another thing I noticed, when we are talking about, and I think this relates to this slide, when you were talking about the delay in the train, it was only from north to south during early morning peak hours. If you check the schedule from south to north, it is not as bad, at least early morning. However, during the peak hours, maybe 10 or 11 to 2 or 3 p.m., it is always late. You can check that.
Okay, I'll check.
So because that also depends on this one. Over here, you are only looking at north to south, right?
No, I'm trying to do both. I've been trying to do both. And there are some differences. The thing is, the problem with the delays is that the delays is not affected to a particular train ID. So it's impossible to know what train are actually affected by the delay. So it's kind of useless. The second problem is that the MTA is actually announcing a delay with a sentence which has been written by somebody. It's never the same structure for the sentence, and sometimes they mix the train line together. So for a computer to understand what train has been delayed is extremely painful and extremely difficult.
And can you try to distinguish between delay on express trains versus on local trains?
It's a possibility. I didn't do it, but it's a possibility. And the second problem that I had is that as I made the mistake of downloading the data every 5 minutes on the advice of one of my teachers, when I actually was trying to track the train when they arrive at the South Ferry, the number of trains that I had downloaded was reduced, because the thing is I need the time here and I need the timestamp here. So in order to actually get some consistent data, I actually had to track the train passing here, and then passing on rector strip or sphere to get something more significant. So if I had to improve this algorithm, I will actually download the data more frequently. I will use SQL instead of using a text file because the text file is extremely difficult yes, too slow, and it's extremely difficult with the Shiny app to load and to analyze. I will do for sure the analysis on a longer period because we had only 10 days to do the app. I don't need the data for 6 days. We at least need 1 month to do something more significant, most likely 1 year. And we need to separate the weekdays from the weekends. Also, one of the things that I wanted to do is to calculate the speed between the stations, and finally understand why the 4 train is so slow, because it's an express train, and why is it so slow compared to the 1 train. And then, as you suggested, try to do a study if you were jumping from the local train to the express train, and see if there is a gain in terms of time. The last part that I built at the last minute, so I spent approximately 1 weekend on the map. I spent 7 days on the study for the travel time, and then spent 4 hours on the real-time map. The reason being is that I used all the code that I had done for the last week for the real-time map. So once you have done, if you go through my code carefully, if you do the first 2 parts, it will be extremely easy for you to do to understand the real-time map. So I also give you 2 possibilities. So this is the solution that I did for the presentation 2 months ago. So I actually have a Python script which is generating a text file, and the Shiny app is reading the text file every 30 seconds. With a new, after my teachers insisted. Now this is the Shiny app which is calling the Python script and getting the data to be able to draw them. So here is the same Shiny app locally on the computer, and here is the real-time map. So if you wait, you are going to see that the train are actually moving. Again, this is expected time. This is not the exact real time. And you can change. You can put from direction south, and you can also pick the line number 6 instead of taking the line number 1. Any question?
Observations and questions. One is your observation that the 90-second thing, that's consistent with the signs. You see on the signs sometimes it says 2 minutes next train and it goes 0 instead of like 2, 1. Two other things. The slowness on the 4, you're probably going to find that's a function of the platforms. Because if the subway platforms don't have good egress, and during rush hour a lot of people get off on the platform, the conductor is afraid to roll the train so people get away from the edge of the trains. So there's some stations just, they're architecturally limited in terms of their egress. So the platform is very crowded and the train's got to stand there for people to step back. Finally, it would be really cool to have like a model train simulating this, have the trains move around the track. That would be so cool.
And to go back to my...
There are labs that do that right now.
Who they do it? Where?
Um,
At the museum?
no, you can.
So my next presentation will be on September 28th. I will present a project that I did with Spark and Python. Spark being parallel computing software. And I will present a project about the most popular R packages and a visualization to actually see the dependency between the R packages.